Guys, in this video, let us discuss about Schrodinger time dependent wave equation. This time dependent wave equation is obtained from Schrodinger time independent wave equation by eliminating E. Right? By eliminating E in the equation. So now, once let us write what is the time independent Schrodinger wave equation. Time independent Schrodinger wave equation. What is that? Del square psi plus 2m by h square e minus v into psi equal to 0. By eliminating this e, we will derive time dependent wave equation. Right? Now for that, as usual, Schrodinger introduced the wave function to describe the behavior of the particle in the quantum mechanics in terms of space as well as the time. Right? Now the classical wave equation or the differential equation, of one-dimensional wave motion. In last video, we discussed time-independent Schrodinger wave equation. What we wrote? Dou square psi by dou t square equal to v square. Dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square. Now this is written as v square del square psi dou square psi by dou t square. Put it as equation 1. What is del square? Laplacian operator. That is dou square by dou x square plus dou square by dou y square plus dou square by dou z square. Laplacian operator. Alright? Laplacian operator. Okay? Now, let us write the solution of equation 1. Right? Let us write the solution of equation 1. For that, we are considering the psi to be the complex function. We are considering the psi to be the complex function of space coordinates of a particle and time. Right? A complex function in terms of space coordinates and time. That is how we will write psi. Space coordinates x, y, z, time t. So the solution becomes psi naught x comma y comma z comma t e to the power of minus I omega t in terms of complex terms. Right? Now, this can also be written as psi is equal to psi naught e to the power of minus I omega t. Put it as equation 2. Okay. Now differentiate 2 with respect to t. Now what you will get? Dou psi by dou t is equal to psi naught. Now differentiation of e to the power of minus I omega t, e to the power of minus I omega t, and differentiation of I omega t minus I omega. Okay, differentiation of e to the power of minus I omega t equal to minus I omega e to the power of minus I omega t. Alright. Now in place of psi naught e to the power of minus omega t, you substitute psi. So what you will get? Dou psi by dou t is equal to minus I omega. In place of this, I am substituting psi from equation 2. Okay, I placed psi. Now what is omega? The value of omega, 2 pi nu into nu. Okay, so now it becomes minus I 2 pi nu into psi. This is nothing but dou psi by dou t. Now we know that E is equal to h nu, where E is the energy of the particles, h Planck's constant, nu frequency. So from that, nu can be written as E by h, right? Now substituting this here, now what we will get? Dou psi by dou t is equal to minus I 2 pi E by h into psi. Okay. Now put this E psi here only. I'm sending the other terms to this side. What we will get? Minus h, okay, by 2 pi. Okay, I'm sending this to this side into I dou psi by dou t. Right? This entire term I sent on this side. Now, what is h by 2 pi? H cut means what? H by 2 pi. Substitute no. E psi is equal to minus h cut I dou psi by dou t. Okay. Now, next. Now here, on this side only, minus h cut I, sorry, here h by I, h minus h cut by I by multiplying and dividing by I, dou psi by dou t. What is the value of I square? Minus 1. Now substitute minus minus plus. So I h cut dou psi by dou t. Right? So E psi is equal to I h cut dou psi by dou t. Now, what we have to do? We have to remove E from these equations so that we can get time dependent wave equation. Now, in place of E, you substitute this. Okay. So now, what is time independent wave equation? Del square psi plus 2m by h cut square E minus V into psi equal to 0. Right? Or del square psi plus 2m by h cut square E psi minus V psi is equal to 0. Now in place of E psi, now I am substituting del square psi plus 2m by h cut square. What is E psi? I h cut dou psi by dou t minus V psi is equal to 0. Now next, del square psi plus del square. I am sending the complete term on this side. I am placing del square psi on this side only. It becomes minus 2m by h cut square I h cut dou psi by dou t minus V psi is equal to 0. Sorry, not 0. Minus 2m by h cut square I h cut dou psi by dou t minus V psi. Okay. Now next, we can also write this as, I'm sending this to this side. What I will get? Minus h cut square by 2m del square psi. Okay. Del square psi is equal to what I will get? I h cut dou psi by dou t minus V psi. Now I am bringing V psi to this side. What I will get? Minus h cut square by 2m del square psi plus V psi is equal to I h cut dou psi by dou t. Now this we call it as Schroedinger time dependent wave equation. Now in equation we are seeing dou psi by dou t. That is time dependent wave equation. It indicates the time-dependent wave equation. Further, in terms of Hamiltonian operator, if you want to write, now what we got? Here again I am writing minus h cut square by 2m del square psi plus v psi is equal to I h cut dou psi by dou t we got. The time-dependent wave equation. Right? Now next, here psi I am taking common minus h cut square by 2m del square plus v into psi is equal to I h cut dou by dou t psi. Now this is nothing but Hamiltonian operator. Hamiltonian. Now here minus h cut square by 2m del square is kinetic energy operator. And V is potential energy. And Hamiltonian operator means which explains about the energy of particle in quantum mechanics. So it is denoted by H, Hamiltonian operator. And psi as usual I am writing. Now here from this equation I can write this as E is equal to I h cut dou by dou t. So this is nothing but energy operator. I can say energy operator. So this is nothing but energy operator. Alright. So this is energy of a Hamiltonian operator minus h cut square by 2m del square plus v Hamiltonian operator I h cut dou by dou t is energy operator. Correct? It is energy operator. Okay. So now in such a way this particular equation describes the motion of non-relativistic material particle. So this is about the time-dependent Schrodinger wave equation. Okay. In my next video, I will explain about the time-independent, the comparison of time-independent and what are the time-dependent Schrodinger wave equations. If you like my video, share it, subscribe it. Thank you for watching. Yours, Reshma Physics.